We've had a unit dedicated to liquids, but we haven't had one dedicated to gases yet. And there's laws that govern the way that gases behave in regard to what gases do if you change their temperature, what gases do if you change their pressure, and they're very formidable. So gases are kind of fun to study, but they're also very quantitative, which is why you'll always have a calculator. There's 3 mini topics that I want to go over today. The first one being the easiest calculation I've ever shown you in this class. Your eyes are going to widen and you're going to think I'm leaving something out. But the very first thing that we need to do today is be able to convert between temperature scales. What temperature scale do we use? We use Fahrenheit. How did you miss that? Yes, we use Fahrenheit. Now he said Celsius, and Celsius is actually a pretty good answer everywhere else in the world. We're pretty much the only place globally that uses Fahrenheit as our country scale in regards to looking at temperature. The majority of the world uses Celsius. The chemistry world, or science world rather, focuses more on Celsius than Fahrenheit, but there's even a better scientific scale for temperature. Does anybody know what it is? It's Kelvin. I like the way you did that, like you were telling me a secret. That's awesome. Yeah, it's Kelvin is the scientific universally used scale. Unfortunately, when we're given data to run, especially in regard to these gases that we're about to start looking at, real life will usually give us Celsius, and that's no good because all of the analysis that will run on gases has to be in Kelvin. So you need to know how to convert from one to the other. Now, we won't talk about degrees Fahrenheit in here. There is a way that you can convert between Fahrenheit and Celsius and Fahrenheit and Kelvin. Here, take one of these. But since Fahrenheit is overwhelmingly unused on the planet, Celsius, or degrees Celsius, and Kelvin will be the 2 things that we focus more specifically on. If you take a look at the front of your new cheat sheet, there's a section called Temperature Conversions. It shows you how to find Kelvin and how to find Celsius. So let's start with the Kelvin. You write what I write. To find Kelvin, you take the degrees Celsius reading that it gives you, and you add the number 273. It really is that simple. So if right now I said it's 40 degrees Celsius outside, and I want to know, well, what is that number in Kelvin? In order to find Kelvin, I take that number of Celsius and I add 273 to it. And that will give me a Kelvin reading. That would be 313 Kelvin. Notice how it's not degrees Kelvin. All right, I'm kind of a stickler for that. It's degrees Celsius, but it's just Kelvin. So 40 degrees Celsius is the same thing as 313 Kelvin. So what if it's 1 degree Celsius? It'd be 274 Kelvin, right? That's pretty easy. 273, we're adding to get there. It would be 274 Kelvin. Now, one thing that temperatures can do, and it really shouldn't cause you trouble at this point in your life, but temperatures can be negative, right? Not often where we live, but it could be negative 10 degrees Celsius. And if I want to know what that is in Kelvin, well, same thing. Take the degrees Celsius and add 273. What's the answer? Now, some of y'all can just do that in your head. You know how integers work. Yes, 263 Kelvin would be the answer. But you do have a negative symbol on your calculator. So if you really like to double check the way that you've learned to do this kind of algebra, just use it. Just type in negative 10 plus 273. It'll give you an accurate answer. Now there's another temperature conversion on your cheat sheet, because occasionally you'll need to go the other direction, which is just as easy. If I want you to find degrees Celsius, well, then you take the Kelvin reading that you currently have and just go the other direction. Subtract 273. So if we said that it was 400 Kelvin, and we want to know what that is in degrees Celsius, to find the degrees Celsius, you take the Kelvin reading that you have minus 273. And what will I get here? 127 degrees Celsius. Of course, our units are essential. You try a couple. Solve both of those. Let me know if I can help you. Even though this equation is very simple, your brain does get mixed up sometimes. Even you smart kids out there get confused on which direction to go. So one thing that can help you is remember that Kelvin is always bigger than Celsius. Remember, wherever the K falls needs to always be a bigger number than wherever the C is. So looking here, if I'm going from Kelvin to Celsius and I realize, well, the number I'm missing is supposed to be smaller than that, then right away I know it's subtracting 273 that I need to do. The number's always 273. I'll give that to you on the test. It's an equation. I always give you the equations. But sometimes that's helpful. But to find Celsius, it's Kelvin minus 273. What is 409.5 minus 273? 136.5? Whoops. All right. Going this way, Kelvin's what's missing. I know the K number must be bigger than the C number. To find Kelvin, it's degrees Celsius plus 273. What's negative 32.1 plus 273? 240 what? 240.9? Anybody get different answers? That's our first of 3 mini skills that we need to do today.